Push the record button, eh? So there's my flow tracing. I'm going up to 30, staying there for 1 second, dropping down to whatever peak expiratory flow you want, but I also have auto peak present, so I have to come back to something other than 0 when the next breath starts.
And that doesn't matter where you are like coming back from.
No. Or where you're coming back to. These are different.
Right. So
So
that doesn't matter.
that's different. So how about volume? My tidal volume is 500. One of the things that we were talking earlier, people like to draw 2 dots to start with. My starting point, my ending point, and then just connect the dots. Here, I'm going to have it so that when they exhale, they don't fully exhale. There's some air trapping. It then zeroes itself out before I go to the same tidal volume on the second breath.
Is this one the shark?
So again, we're going up to the 500, and we know we're going over to the 1 second because that's the
That
inspiratory
over to the
time. No, I'm talking about in the volume.
yeah.
So up to 5 and over 1 second because
Yep.
that's the inspiratory time.
Yep.
And then we go back down to 3, but not all the way back down.
Right. Now, couple of things I drew 2 different graphs here. On the first one, there's some air trapping. The inspired volume does not match the expired volume. It's actually stopping right here.
So inspired volume doesn't match it, so
Expired doesn't match inspired.
so expired is less than inspired?
Yes, it is. Now, if I saw that on every single breath, that's a leak. If I just see it on some of them, it's air trapping. So notice what happens on the subsequent breath is it comes down to here. Because eventually some of that trapped air has got to come back out again. So now my expiratory volume is bigger than my inspiratory volume.
So you said if we saw just a bunch of the first one, it would be a leak.
That'd be a leak.
And since
What
the
is
second
it?
one went under, it means air
I've
trapping.
exhaled out more than I put in.
Okay.
The only way that could happen is if I'm depleting some of that trapped gas I have.
How do I know it's leaking?
Because the inspired volume and the expired volume are different. I'm putting in 500 but only getting back 480.
How do I know that though? How do you know you're only getting back to 480?
Because that's what happens with air trapping. You would
But
know
how
it
do I
because
see that on the graph, I guess? How do I?
it doesn't come all the way back. There's like 50 or 60 cc's that are still trapped. It comes back to the point where the next breath starts, but it hasn't fully exhaled.
I'm really confused. Maybe I'm not seeing this right. Because this is coming back to 3, right?
But my point is no.
It's not.
Right.
There's gonna be like a cut, right?
So it's coming back to there. So this little bit right there is the air trap.
That's right.
And now
And
with
how much
this
air
breath-
trapping do I have? I can actually quantify how much air trapping.
Okay, but with this next breath, you're saying start
Start right
while
there.
there's still the air
Right.
trap.
That vertical line where it comes down is basically the ventilator resetting itself.
Oh, okay, that's what I was wondering too. So it's still connected.
So the ventilator has to start at 0. So if it lands on that where the expiratory time ends and it's still shy of 0, the ventilator's going to reset itself. That's why that vertical line is there.
So the second arrow is going.
The second
Yes.
the second one is where I'm exhaling more than I have going in. And the reason for that is with air trapping, at some point,
You have to exhale.
you're just going to exhale more than you put in.
So is there a gap? So look, I drew mine like this, so is there that gap right here?
Yeah, you've got to have a line connecting the two. Got to have a vertical line.
So like this, it'd be a
Correct.
straight line like
Correct.
that.
And the same thing is technically true here.
So here's
So what do you mean by vertical line with this? How long is the blade when it's air traffic? So, I guess we have to.
Yeah, so this would be vertical.
Vertical line right there. Supposed to be on there. Well, no, cause
And
you
this would
still
be
start at 0.
Okay.
Yeah. So one
Can you
goes
see
to
the
0, one goes to
It's
1.
Right.
Is this right then?
I just wanna make sure.
Yeah, and then the 3 is
So
going.
is this
Yep.
starting
Yep.
back right here?
Yep, that's resetting it back to zero
Is
for
it,
start next
okay, so
round.
this is what it's starting and I'm just going over 1 second, right?
Right.
Every single time?
Right.
This really is not.
Next time you have a COPD patient on a ventilator, watch their exhale volumes. They are all over the board because of air traffic. Okay. Who's left? Pressure tracing, right? What is my flow? Hello. What is my waveform flow pattern? What is my flow waveform pattern? Square. So what kind of a pressure-based breath will that generate?
Linear, and then goes
A straight line rise, right?
straight line like this.
Where am I going to start this straight line?
At 5.
At 5. And what is my peak pressure?
25.
25.
So that's 5. So do you do anything here because there's air traffic?
Yes, that pressure tracing needs to come back to baseline at the point where the next breath starts.
You're gonna go back to 5 and then you're gonna. So there's no pause in between.
Correct. There's no pause that I'm at baseline. Once flow is stopped,
Right away.
at that point then the pressure should be 0 or baseline.
Wait, so where is the air traffic? Oh.
It's going all the way back. Instead of having something where it's coming back like this.
That's how it should come back?
That's how it would be without air traffic. And remember, that point has to align with that point, with the actual line with that point. That's why you get a, there's a half a point.
I'm really bad at drawing maybe. Is that wrong then? Like, so it, without air trapping, it should come back before, but that
Correct.
still is air trapping all
Correct.
of this right here. Otherwise, it would come here and then flatten out right
Correct.
at 5. Okay.
Correct. All three of them have to align. That's the important thing to remember. And I think that's worth a half a point.
All three of.
All three graphs. The start of the breath, the end of the breath has to be the same.
For the pressure, flow, and volume.
But do these align?
Yeah.
I guess so.
So then like the start here, right, and that's the end, that has to match up to the
Yeah, yeah. So the end and the start are the same. The end and the start are the same. Cool? I had fun. How about you guys?
Nope.
Sorry.
But they should
Is
all.
it getting better?
Yeah.
Yeah.
I'm getting there.
Yeah. But they should all line up then if you're doing.
Yes, they
I
should all
guess
line up.
I'm so confused at how we got the 3 seconds though. The
20
breath every 3 seconds.
60 divided by 20.
Yeah, just the
The flow divided by.
60 divided by 20, which is the respiratory rate. Total cycle time is 60 divided by frequency. Always, always, always. Should we do a pressure-based breath?
Yes.
And by the way, Amber finally pulled this out for me.
There's a customer that has that.
I have too much fun with that.
What is that?
It's electrolarynx.
And you're on video too. So like you put it on and then you talk?
Yeah, it vibrates your larynx so you can talk. If someone who has a laryngectomy wants to speak, that's the way they speak. All right, pressure basin, right? I'm going to graph the pressure tracing first. Then I can do the flow and the volume. Same respiratory rate of 20, so every 3 seconds I'm going to have a start of a breath. I'm going to start, I have a baseline of 5 and a peak pressure of 25. Now on the test, it may appear one of two different ways, just to make it interesting. If it says set pressure, that's my pressure control level. If it says measured, that's where it's actually going to.
Measured or observed, right?
Or observed.
So measured is the one you want.
I don't know what you want, but I'm just saying if it says set, that's a different picture. If I have this set up with 5 a baseline, and I say that that I have a set pressure of 20, it's going to go from 5 to 25. If I have an observed pressure of 25, that means my delta is only 20.
So you would go to 20. You'd start
No, I
at
go to
5.
25. If it says observed pressure, it's going to end at 25. If it says set pressure and the set pressure is 25, it's going to go from 5 to 30. You need to pay attention to what information you begin. Because my pressure control level.
It's a pressure
Okay,
level.
let me draw them both.
You set these, whatever they give you. That's what I
Right.
said.
No, I understand he's saying something that's not up.
Yeah, it's another slide that we have in the book. For those confused too.
So that would be peak plus peak.
Yes.
That's how
That
you're
would
getting
be,
the 30
so it
is
says
the
set,
peak?
you would add the peak and the peak together.
Yeah.
Not peak
So the first example
plus peak.
is observed. My observed pressure is 25.
And then if it's
The
observed,
second one
then
says
it's
a
just
set pressure of
the
25,
observed.
starting at 5 and going to 30.
Whatever observed
So
is.
observed, you're doing exactly what it says.
That is correct.
Set, you want to make sure that you're starting where you're adding in the peak.
Yes.
So where would that be when you, would it be like,
It would say on the pressure 25 set,
Oh, say it right.
25
That's
observed.
So if it's
Okay.
set at 25 and you have a peak, let's say
It
you're
says 25
Peak
set
five.
and
peak of 5, you're going to 30.
Correct.
But
So
if it's
5.5
observed, you
you
just
change.
go to the
so just
What it's
set
observed
is
at.
P plus
Okay.
peak?
Yeah.
Okay.
We
And then
good
that's
on that?
Whatever
Yeah.
the peak
Okay.
is.
Be careful, be careful, be careful.
Okay.
But,
So my I time is 1. Go ahead, Albana.
so your
Right,
peak is
just
5.
when you think you're getting it.
And
Mhm.
the peak pressure is 25, so we put it at 35. You
Yeah,
put it at
I just
25.
realized something we forgot to do.
Yeah. I saw your videos, we said most we do this wrong.
Trigger.
Yep. I thought so. I just wasn't.
What
Yeah.
did we forget?
Thanks for catching me. Patient trigger.
Yeah, that's patient triggered also, okay?
Okay,
So if it's patient triggered, you can see this only in the pressure waveform.
Yep. Technically you'd see it in the volume too, but
Okay.
don't worry about that. So here I have auto peep also, don't I? And I have a rate of 20.
What did you do for the trigger? You put it like there's a notch on the pressure.
No, no,
We just
still
thought we
on
did
the
flow
other
first.
pressure.
Are we doing flow first?
No, pressure.
For this one that you're drawing.
Where did you put your
Okay,
marker?
pressure
So
rate,
put it like
pressure
this.
size?
You know, we go down here. The rest of it would be like
Rick?
here.
Yeah.
For this one,
How do we know
Like
it's
you said the PEEP is 5.
Yep.
We said the peak inspiratory pressure,
And a patient for pressure
Is-
ventilation.
peak pressure at 25, so 25 plus 5, 30.
No.
Not in
The
this case,
that's in the I should have wrote in there observed.
this is the observed
That's
one.
not set.
Okay, so.
If it doesn't say set, I can't assume that it's set.
Okay, so we're doing it observed.
We're gonna, and on the test they'll be very, very clear.
Okay.
So this is.
So these are
This
all
one's a
observed,
25.
yeah.
Okay.
Is the peak pressure only in, like, when you set or observed, will it only be in pressure ventilation or both?
Yeah. Oh, volume is always observed.
No,
We
I
don't-
mean
we
the
don't
peak
set a-
pressure.
We don't set a peak pressure in volume based. Right?
No. Only flow in the.
Only flow and volume.
Correct.
Okay, I get what you're saying.
Well,
This
thank you.
pressure's variable.
Oh, you-
Did you find the slide? The slide on 5?
What does the flow pattern look like in pressure control?
Variable ramp.
No, it's called exponential.
Yeah, it's called exponential decay.
Yes.
So it's going to start, and I go up to 60, I believe.
Oh, flow.
Oh, you're done the first one.
It should have some little curvature to it.
Wait,
It's unlike a ramp in volume, it's got a little curve. What's wrong?
We're a little behind.
I'm not going to say that. That would be rude.
How do we know what we're drawing? So, all in 1 second, you're doing,
What?
I guess I just don't understand, like, how do I know that I'm supposed to be drawing that?
Because a pressure controlled breath always has an exponential decay or variable ramp.
And then that thing up there,
That's what this is.
I don't understand it, so.
yeah, that thing.
Okay, let's explain to grandma how a pressure controlled breath.
Well, I am
Work.
grandma, so explain to me.
When the unit turns on, a high flow rate is exposed to the airways. So I show real high peak flow. Okay. What determines that how much flow is there is the rise time. Is it here or is it here? Okay. Higher rise time means I'm going to rise the pressure quicker. Once those airways are pressurized to my target pressure, then the flow starts to decelerate until the point where at the end of the breath, all the lungs are full. So what you're filling are basically small airways, which are very laminar. Towards the end of a pressure controlled breath.
So how do you, like, even if you're in the volume control, how do you know in the flow if you're using a square?
This is fixed. This will never change. You change compliance, you change resistance, this will not change.
Okay, but how do I know which one?
Stop. In a pressure-based breath, the shape of that is going to dramatically change when compliance and resistance changes. Because the flow and the volume are going to change. Flow and volume are variables in a pressure-controlled breath.
I still like that top part, if it's like the point, like the pressure and the
This
volume.
is a straight line. This has got a curve to it.
So, but the flow, like, do I know that because it says that it's square, that's how I'm drawing the square in the flow, or if it's descending, but what about the pressure then? What about the pressure?
Pressure will either be in a square line, a straight line rise, or in a decelerating ramp or the sharp line. Pressure is always going to be an exponential decay.
So pressure will always look like those two.
Yeah.
It's always gonna look like that,
Yeah.
for pressure and flow in
Yeah.
pressure control.
Yeah, in a pressure controlled breath. How we doing? Is it better? Emily, lie to me, would you?
The first one was better, but this one, now I'm confused.
What am I gonna do with you?
Yeah, no, I'm not even.
Maybe I can sell you.
Okay,
Can we
so
take
since it was pressure,
Can we take some of
base,
these, like more
we're
of these at
doing,
home?
what's that thing set over there with the little circle?
This is called an exponential decay.
Yep, and
This
what's,
one's still up to
and we know that we're doing that because
Yes,
why?
Because I'm in pressure control.
So every 3 seconds.
Okay?
Pressure control will always have a square wave flow pattern. I'm sorry, square wave pressure pattern, and always have a decelerating exponential decay.
Okay, so then what are the other ones next to it? What's the sharp and decelerating?
So if this is volume, this is pressure. In volume, if I have a decelerating ramp, I'm going to have a sharp fin. If I have a square wave, I'm going to have a ramp.
Okay.
Yeesh.
This is
is a nightmare.
But the nightmare's getting longer. Actually, the nightmare's getting shorter because we're getting better at it.
You say so.
10 points on the exam.
That's a lot, I'm just
a
kidding.
lot. We all know it's a lot. Thanks, Rick.
I want those 10 points.
You want to get that grade up. What about the volume curve? Screw it. Let's just go home. Volume is easy.
0.5 liters. Question, when we're doing all these, are we gonna have like, like flow would be 0 to 60 kind of deal, and pressure would be 5, go by 5s up to 40? And
However you want to draw it, just so I can make out what you're what
I just
you're
don't know if
doing.
that's like kind of like a base for that.
So volume always looks like that then. Volume never changes its shape. For volume or pressure, it still looks like that.
Pretty much. Volume time traces are boring. The only thing you can really use them for is auto PEEP and leaks. I think we talked about these. Shut up, Rick. Thursday? How about if we do another couple of tracings?
Yes, please. So for volume, we're going to,
0.5.
okay.
No patient triggering. It's all machine.
Which means we would draw that little notch then.
Correct.
So this basically looks like, just like the other, in this case 1 volume. It pretty much looks exactly the same.
The pressure tracing?
The volume tracing. Looking the same except for the air traffic.
Are you saying the right looks like the left? I wouldn't say that. Your pressure are totally different. Your flows are totally different. Your volumes are totally different.
That's what I'm saying, the volume.
Oh, the volume, yeah.
Yeah, I'm saying that tracing should look the same to me.
Yeah, they are.
Okay.
We good?
Nope.
All right, we'll stop.